Welcome back. This is Professor Ridge, and today's lesson is on section 5.6, factoring sums or differences of cubes. So just like we had the formula for difference of squares, we could do it for cubes also. So let me write those down. A cubed minus b cubed. Okay, so a difference of two cubes, a cubed minus b cubed, and the formula is you're just going to do a minus b, and then a squared plus ab plus b squared, and then for some two cubes it's exactly the same thing except the first sign is a plus and minus, and then the last one's always plus. So think of these as positions. So think, let's try a couple. If I want you to factor, say, x cubed minus 27. So the idea is you're going to take the first term and cube root it. Cube root. So think of it as positions. So you take the first term, cube root it, so that's x. Take the second term, cube root it. So what to the third power is 27, so that's 3. And it's going to be minus 3. You notice it's the same sign, the first one, as if it's a difference, that's a minus. If that was plus, that would be plus x plus 3. Alright, and then from there, again, if we look at the formula on top, it's a minus b and then a squared. Think of a as the first term from this parenthesis. So we're going to square it. So that would be x squared. And then you multiply these two numbers together. So x times 3. And notice that that sign changes. So now this will be plus. And then you're going to square the last term. Square. So that gets you 9. So it's simple as that. Let's try another one. So if I want to factor, say, x, well, let's do 8x cubed plus 125. So you're going to cube root both of them. So 2x plus 5. You're going to take the first term, square it. So 2x times 2x is 4x squared. Multiply these together, so that's 10x. And then you change the sign. And then you're going to square the last term. So that would be 25. And of course you don't write all the arrows, I'm just doing it for your notes. Okay, let's try another one. Okay, so let's try 6y cubed minus 384z cubed. And again, your first step always in factoring is look for common factors. So does anything divide out of these two numbers? And let's see, how about 6? You divide out 6, you get y cubed minus 64 z cubed. Okay, now it fits the formula, so a, here, just to kind of see, no, you're going to cube root both terms, so a is going to be y, and b will be, let's see, 4z. So we're going to leave the 6 out in front. Cube root the first term, that's my a, that'll be y, minus, cube root the second term, 4z. And now again you're going to square the first term and square the y. So y squared. Multiply them together. Change the sign. And there's no 2 on here like for the difference, or for the when you do square binomial. It's just multiply them together. And then you square the b term. So that'd be 16z squared. And you're done. course, you've got to check, make sure nothing else factors, but it doesn't. All right, let's try another one. So how about this is 38 from the book. And you get 125 c to the 6 minus 8 b to the 6. Now when you do cube roots, right, this is going to be 5c. You divide the powers by 3 when you do cube roots. So 6 divided by 3 would be 2. This would be 2b squared. And then you're going to square the first term in the parenthesis. That's your a. So a squared would be 25c to the 4th. Multiply them together. That would be 10. And then change the sign. So it would be 10c squared d squared. And then square the last term in the first parenthesis. So that would be 4b to the 4th. And you just memorize this pattern and use the pattern over and over again. All right, one last one. Maybe I better make it 2 last ones, all right? Okay, number 44, p to the 6 minus q to the 6. Now, if you have a choice, this could be done as difference of squares or difference of cubes. And if you have both of those, you should always do difference of squares first. So if you square root it, you get p to the 3rd. So remember, I'm going to use the formula for difference of squares is a plus b, a minus b for difference of squares. So 6 divided by 2 is 3. So there's your difference of squares. And now these are, the first one's a sum of cubes. So it's p plus q, p squared minus pq plus q squared, used just straight from the formula. Now I'm going to do the difference of cubes, same thing. P minus q, square the first one in the first parenthesis. Multiply them together, change the sign, then square the last one. And there you go. Now, just a note of warning here is, again, if you have a choice where you could do squares or cubes, you want to do the squares first, then the cubes, because if you did it the other way, and you factor it as cubes first, you would go p squared minus q squared, and then get p to the 4th minus p squared q squared plus q to the 4th. Oh, that should be plus. And then the problem is this first one factors to p plus q, p minus q, but the second parenthesis, it factors to p squared minus pq plus, it factors to that times this one, but we don't know how to do it from there, and you would get stuck. So since we don't have any technique to factor this one, we would end up with the wrong answer if we did it this way, which is not right. It's right. It's not completely factored, but there is no way for us to go. We don't have a technique, at least not yet, that we can factor it from this p to the 4th plus p squared plus q squared to the 4th to be what it is above. So, you just have to remember that if you have a choice between squares and cubes, you're going to do difference of squares first, and then use the cube formula. All right. So that's all there is to this section, really short and sweet, just using the formulas for differences, sum and difference of cubes. Go to my math lab and complete your exercises there, and I'll see you next time.